Hello, this is Professor Broker, and this is your Chapter 13, Lecture 2 for Econ 231, the cost of production, Part 2. Let's get started. So remember, we looked at the production function last time, which was a relationship between inputs and outputs, and they exist in lots of places. They exist when you're studying. They also exist in business enterprises. That's essentially what a business is. They have a production function, right? They take inputs and they're producing some sort of good or service as an output. Okay? Our example was Farmer Jack, who as he hired more workers, which was his input there on the x-axis, he got more output. We remember that the shape of the production function for Farmer Jack was getting flatter, which represented diminishing marginal product, right? Remember we had our table where we filled in the marginal product, value of marginal product, concepts. Now we want to get more to the cost concepts, okay? The cost concepts, okay? So what are some costs that Farmer Jack might have? Well, let's just say he pays $1,000 per month for the land, regardless of how much wheat he grows. He pays $1,000. So think about that. Regardless, if he makes nothing, or if he makes 5,000 bushels, he still pays the exact same cost. Okay? What is happening to this cost? Is it changing? Is it varying with his output, or is it staying fixed? Okay? Another type of wage he might have is he's paying his workers $2,000 per month. Okay? Now, remember, his output changes with the number of workers he hires, and think about his total amount of wages he's paying. Would that vary with the number of workers he hires? Of course it would, right? And then thus would the amount of wages he pays vary with his level of output, okay? Or would the amount of wages he's paying stay fixed regardless of how many workers he hires, okay? Well, in answering these questions, hopefully the answers were obvious, right? I mean, his land cost was what we call a fixed cost. It's a cost that does not vary with the quantity of output produced, okay? And so, again, his land cost here is fixed. Cost of equipment for a business, right? They might buy, so Farmer Jack might buy a tractor, right? And, he might just purchase one, and if they grow nothing, he still has the tractor. If they have 5,000 bushels, he has still the one tractor, and depreciating that over time, that would be a fixed cost. A loan payment, right? Taking out a loan to start a business. A rent payment. Maybe we're renting an office space. If we serve one customer this month or 1,000 customers, that rent doesn't change. That's a fixed cost for a business. Okay. Variable costs, though, vary with the quantity of output produced. And so the wages that Farmer Jack pays his workers will vary depending on the number of workers he hires. And the number of workers he hires will vary the amount of output that he can produce. Okay. Other examples of variable costs are cost of materials, right? So maybe Farmer Jack uses fertilizer. Well, obviously, if he plans on harvesting, or planting, 5,000 bushels of wheat, he's going to need more fertilizer, as opposed to if he's going to leave his land fallow and not grow anything one season, he's not going to need any fertilizer. So that would be a cost that varies with the amount of output. Okay? Total costs for us, or for Farmer Jack, are going to be fixed cost plus variable costs. So both of them together equal our total costs. Okay? So now let's go ahead and plug in these values. The land cost is a fixed cost. And remember, no matter how much Farmer Jack produces, it's going to remain the same. So what can I put all down this column? Well, obviously $1,000. No matter how much he produces, his land cost is still going to be $1,000. Okay, but what about his variable cost? Okay, that's going to depend on the number of workers he hires. Okay, which is going to influence the amount of output he has. So, if he hires no workers, what's his variable cost? Okay, 0. Now, something I want to point out. Okay, is notice. Okay, again, total cost is going to be fixed plus variable cost. Okay, and so total cost right here would be 1,000. We'll look at it in just a second. But I want you to notice how many workers is Farmer Jack hiring at this level, and how much output is he producing? Nothing. He's got 0 workers and thus 0 output, but he still will have a total cost, right? And that's because he has a fixed cost. Okay, so in the short run, when firms have fixed costs, they still have to pay that fixed cost even if they aren't producing anything. Okay, so even if quantity of output is 0. So that's a very important implication. Okay, But here, so he hires the first worker, okay? How much will that cost him? That will cost him $2,000. He hires the second worker. That will cost him an additional $2,000, which for a collective $4,000 of wages, right? The third worker will cost him an additional $2,000 for a total amount of labor cost of $6,000, then $8,000, then $10,000 for the fifth worker, okay? Now, we get our total cost simply by adding, okay, the fixed plus the variable. Again, I pointed out that even when Farmer Jack is producing nothing, he still has some total cost, which is exactly equal to his fixed cost at zero output, okay? Then we add in this fixed plus variable, 1,000 plus 6,000, 1,000 plus 8,000, 1,000 plus 10,000, okay? So we filled in the table. Now I want to graph his total costs, okay? So basically what this graph is the output that Farmer Jack is able to produce based on his production function on the x-axis and his total cost in dollars on the y-axis. So again, I'm plotting this column against this column. Okay, this column against this column. Now, this column looks like it's increasing linearly, right? It's increasing sort of just by 2,000 each time. That's because it's based on, I mean, you're looking at it based on the number of workers, right, which increases their wages. For each additional worker, it increases by 2,000. But that's not how we want to look at total cost. We're looking at it against the amount of output that we're able to produce. Okay, and notice that the level of output we're able to produce is increasing, but at a decreasing rate, even though our total costs are increasing at a constant rate. Okay, based on the number of workers. That gives us, in other words, a total cost function when we graph cost versus output that increases exponentially. Okay, so the question I would ask you, just like I asked with the production function, is the production function, did it look linear? Of course it didn't. It was getting flatter. That represented diminishing marginal product. In this case, our total cost function is also not linear. It's increasing at an exponential rate, which means the more and more output we produce, our costs are going up just exponentially. They're getting higher and higher and higher, right? Without, you know, a substantial increase in output. The question is what is driving the shape of this curve? Okay, and I'm just going to give you a big hint. What was the big driver of the shape of our production function? When our production function was getting flatter and our output was increasing at a decreasing rate, what was the cause of that? You'll remember it was diminishing marginal product was the cause. Remember, each additional unit of input that we hired gave us less and less and less each time because of fixed input, because of other fixed inputs like capital resources. Okay, it's the same story here. It's the same story, right? Think about those workers. We are hiring the third, the fourth, and the fifth worker for Farmer Jack. Those workers each cost Farmer Jack the same amounts, $2,000. But each worker is adding less and less and less, right? The second worker is adding 800 bushels and cost him 2,000. The fifth worker is only adding 200 bushels and still costing him $2,000. And so because of that, we get an exponential total cost function. Okay, we get an exponential total cost function. That's important because of diminishing marginal product. Now, marginal cost. We looked at marginal product. Okay, now we need to look at the extra amount of cost that Farmer Jack might have as he increases his output by 1 unit. This is called the marginal cost. Okay, we can represent it notationally as a change in total cost divided by a change in output. Okay. Now, now why is marginal cost important? Again, just the same reason that marginal product was important, because rational people think at the margin. So Farmer Jack, when he's making output decisions, it would be rational for him to not think about necessarily his overall cost, but thinking about, if I increase my output by so much, what is the extra cost of that increase comparing to the extra benefit of that increase? Okay, that would be thinking at the margin. Okay, so in order to be able to do that, we need to look at our marginal cost. Okay, now to do that, again, we want to look at the change, okay, in total cost. Okay, notice this is a change of $2,000 from 1,000 to 3,000. We got that from the table. These numbers came from the table. Okay, let me go back and just show you. Okay, those numbers are coming from these columns right here. Again, we have output and we have total cost. Okay, and those are the numbers that are right here. Okay, so our total cost in the numerator is changing by 2,000, but what is our denominator changing by? It's changing by 1,000. So this 2,000 divided by 1,000, okay, would obviously give us a marginal cost of $2. Now, for you mathematical purists out there, this is really, because we're kind of doing this in a clunky way, we're not using an actual equation and taking the derivative. This is really the average marginal cost over this range of output. Okay, but again, doing it the way we need to do it for this class, Econ 231, Principles of Microeconomics, this will be sufficient. So our change in total cost, okay, in the numerator divided by our change in output, our marginal cost for this region would be $2 per bushel. The next region would be, again, 2,000 in the numerator divided by a change of 800, which would be $2.50. Okay, then again, 2,000 divided by 600, 2,000 divided by 400, 2,000 divided by 200. And what do you notice about our marginal cost function? Okay, well, obviously it's increasing. And in fact, it's increasing at an increasing rate, isn't it? I mean, we go from 2 to 250 to 3, and then, oh my gosh, we're all the way up to $10. Right? It's increasing at an increasing rate, just like our total cost function was. Okay, it's increasing exponentially. What do you think the reason for our marginal cost increasing exponentially is? It's the same reason our total cost function increases exponentially, and it's the same reason our production function actually becomes flatter. It's the same phenomenon, the diminishing marginal product. Remember, each worker is adding less and less and less output, okay, for us, yet costing the same. Thus, our marginal cost is increasing exponentially. Okay, so here again, we add our marginal cost to our table of data. Okay. Now, another concept that can be important is not just the extra cost of production. That's an important cost that producers need to know about and they will think about rationally and use to make rational decisions. But we also want to know our average cost. What is my average unit of production costing me? That's an important for profit considerations and some other considerations. And so how would we calculate that? Well, it would just be our total cost divided by our output. That's it. Total cost. So again, average total cost equals total cost divided by our quantity of output. Okay. Now, another important feature, just kind of equation that we need to be familiar with, and some other concepts that I'm not going to go into depth. I'm not going to go in depth in here on this lecture, is our average total cost. Okay, it equals total cost divided by quantity. It also equals average fixed cost divided by, plus average variable cost. Okay, so in addition to having an average total cost concept, we also have an average fixed cost concept. How do you think we find average fixed cost? The average amount of fixed cost per unit. Well, it would be fixed cost in the numerator divided by quantity in the denominator. That's how we find this concept. How do we find average variable cost? The average amount of variable cost per unit. We would put variable cost in the numerator divided by quantity, and that would give me average variable cost. These are important concepts, and if we add average variable to average fixed, we would get average total cost. So there's two ways to find average total cost. Okay, but I will say in our examples and problems and on the test, this will be the most useful to you, most likely, is the top one. Okay. Now, usually average total cost curve is U-shaped. Okay, we'll come back to that. The shape of it is typically a U-shape. Okay, we'll talk about why that is, and we'll see an example of that. Okay, but first let's calculate average total cost. Okay, so we calculated marginal cost. How are we going to find average total cost? Again, total cost divided by quantity. Now, I'm going to go ahead and I just want to encourage you to get in the habit. Notice marginal cost is really calculating what's going on between these two units, right? As we go from 0 to 1,000 and 1,000 to 3,000. Average total cost is really at a fixed point in time. So we would want to know, for example, what is the average total cost of this level of production? Well, we would take 1,000 divided by 0. Okay, well, what do you get when you divide by 0? Really, we say it's undefined. We could take the limit and whatever, but we're not going to get that complicated. And so really, it doesn't really make sense, right, to divide this total cost over no units. And so we're just going to put a dash. It's really not applicable at that level of production. Okay, So when you have no production, your average total cost is really just not applicable. Put a dash. Okay. But at the next level of production, we have a total cost of 3,000. We divide that by our total amount of output, which is 1,000. So 3,000 divided by 1,000 is $3. 5,000 divided by 1,800 is $2.77. $7,000, okay, divided by 2,400 is $3.21. Then $3.67, and so on. Okay, and so you see here our average total cost. Now, I just kind of want you to look numerically. Our marginal cost starts increasing smallly and then increases rapidly, so it increases exponentially. What's going on with our average total cost? Right? It starts out undefined, but then here we have a starting point. It goes down, right? It goes down, then it begins to increase. Okay? And if we put our numbers here, okay, our average total cost is going to look something like this. So this is here we have output on the x-axis, and we have our costs in dollars on the y-axis. And here the bluish or purple line is our marginal cost for Farmer Jack, and the red line is our average total cost. Okay? And what do you notice about the shapes? Well, again, the marginal cost is increasing, and it's increasing exponentially. The average total cost looks like it's declining for a period. Okay, then it begins to increase. Okay, like that. Well, I mean, you can't really see it there. If we zoomed in, though, I mean, what shape decreases, has a minimum, and then increases? Well, that would be a U shape, wouldn't it? Right, which is kind of what our average total cost curve looks like. Now, you can't really totally see it here. But you can kind of see it, and I want you to think about what is happening, okay, to our average total cost curve based on the position of our marginal cost curve. Okay, so again, what is happening in terms of how average total cost is changing when the position of marginal cost is down here versus when marginal cost is up here? Okay. I want you to think about that for just a second. Okay? When marginal cost down here, okay, is below, okay, average total cost. So in other words, for these units of production, marginal cost is like at $2, between $2 and $2.50, right? While average cost is up here around the $3 mark. So in other words, marginal cost for this range of output, marginal cost is less than average total cost, okay? When that's true, what is happening to average total cost? Is it increasing or decreasing or staying the same? Well, it looks like it's decreasing, doesn't it? When marginal cost is below average total cost, our average total cost is decreasing, okay, until about here. And then after this point, now this is where average total cost equals marginal cost. And after this point, marginal cost for all these other ranges of output, right? Marginal cost is greater than average total cost, right? It's above it. Well, when marginal cost is greater than average total cost, what's happening to average total cost? It looks like it's increasing, right? So let's walk through this again. When marginal cost for these, starting from this point where they're equal, everything over here, average total cost is declining. And then from this point over here, average total cost is increasing. So what can you tell me is true about this point? Is this point a minimum for average total cost or a maximum for average total cost? Right? Well, it's a minimum, right? I mean, if it's decreasing to the left and then increasing to the right, this is our minimum of average total cost, which corresponds to where marginal cost equals average total cost. Okay? And we have a special name for this point, okay, where marginal cost equals average total cost. It's the minimum of average total cost, which we call the efficient scale, okay, the efficient scale. In other words, it's the lowest average total cost that this firm can achieve, okay? Now, this does not mean this is where the firm is going to produce. It doesn't necessarily mean that this is the profit maximizing level of production. It just means it is the lowest average total cost of production. Okay, right there where marginal cost equals average total cost. So that's an important relationship to make sure that we understand. Okay, so let's go ahead and Fill in these blanks, okay? What you give up for taking some action is called what? Well, you'll remember from chapter 1, that's called our opportunity cost. Something blank is falling when marginal cost is below it and rising when marginal cost is above it. We just talked about that, didn't we? That's our average total cost curve. A cost that does not depend on the quantity produced is what? How about a fixed cost, right? That does not change depending on the quantity produced. In the ice cream industry, in the short run, this type of cost includes the cost of cream and sugar, but not the cost of the factory, right? Cream and sugar would vary depending on output. The factory is the rent on a factory or so on is not going to change based on output. So this would be variable costs change with output. Profits equal total revenue minus total cost. Okay, we haven't really talked about that yet, but we will, right? Profits are total revenues minus total cost. And then the cost of producing an extra unit of output is the, again, extra meaning marginal, is the marginal cost. Okay?